The Dance of Flight, an introduction to helicopter control. Helicopters are unique flying machines that have fascinated people for decades. Their ability to take off and land vertically, hover in place and fly in any direction, makes them incredibly versatile and useful in a variety of situations. Helicopters are marvels of engineering, capable of vertical takeoff, landing, and hovering. This capability allows them to operate in environments where fixed-wing aircraft cannot, such as in urban areas, mountainous regions, and remote locations without runways. This freedom of movement is made possible by their rotating wings, called rotor blades. These blades spin at high speeds, creating lift and allowing the helicopter to rise off the ground. The rotor system is a complex assembly of parts that must work in perfect harmony to ensure stable flight. Unlike fixed-wing aircraft, helicopters generate lift and control their movement through subtle adjustments to these spinning blades. By changing the angle of the rotor blades, pilots can control the direction and speed of the helicopter, making it possible to perform intricate maneuvers and fly in any direction. This complex dance of flight is orchestrated by the pilot using two primary control inputs, the cyclic and the collective. The pilot must constantly adjust these controls to maintain stable flight and navigate through various conditions. Understanding the principles behind these controls is essential for grasping the art of helicopter flight. The cyclic control, which resembles a joystick, is used to change the direction and speed of the helicopter. By tilting the cyclic in different directions, the pilot can make the helicopter move forward, backward, left, or right. The cyclic, resembling a joystick, dictates the helicopter's direction and speed. It is a crucial tool for maneuvering the helicopter and requires precise handling to ensure smooth and controlled flight. The collective, a lever typically located on the pilot's left, manages the helicopter's altitude and engine power. By raising or lowering the collective, the pilot can make the helicopter ascend or descend. This control also affects the power output of the engine, which is crucial for maintaining the desired altitude and performance. Together, these controls empower pilots to maneuver helicopters with remarkable precision. Mastering the use of the cyclic and collective is essential for any aspiring helicopter pilot, as it allows them to perform a wide range of tasks, from search and rescue missions to aerial photography and beyond. The art of helicopter flight is a testament to human ingenuity and the relentless pursuit of innovation in aviation. The cyclic, the helicopter's joystick. The cyclic control, often referred to simply as the cyclic, is a joystick-like device situated directly in front of the pilot. As the name suggests, it operates in a cyclical manner, allowing for smooth, continuous input. Just as a cyclist steers a bicycle by leaning into turns, the cyclic enables a helicopter pilot to tilt the rotor disc, dictating the direction of flight. When the pilot moves the cyclic, it alters the pitch of the rotor blades throughout their rotation cycle. This change in pitch generates a difference in lift across the rotor disc, causing the helicopter to tilt in the desired direction. Mastering the cyclic. Tilting the rotor disc for direction. Imagine a flat plate balanced on a central point. This plate represents the rotor disc of a helicopter, which is crucial for its movement and stability. If you gently press down on one edge, the plate tilts, and the opposite edge rises. This simple action demonstrates the basic principle of how the cyclic control works in a helicopter. The cyclic operates on a similar principle, tilting the entire rotor disc to direct the helicopter's movement. By manipulating the cyclic, the pilot can control the direction and attitude of the helicopter. For instance, pushing the cyclic forward tilts the rotor disc forward. This action changes the angle of the rotor blades, causing the helicopter to pitch down. This directs the helicopter's thrust forward, causing it to accelerate and fly forward. The forward tilt of the rotor disc generates a forward component of lift, propelling the helicopter ahead. Pulling the cyclic back has the opposite effect, slowing the helicopter down or even causing it to fly backward. The backward tilt of the rotor disc reduces forward thrust and can even generate reverse thrust. Similarly, moving the cyclic to the left or right tilts the rotor disc accordingly, initiating a turn in that direction. This lateral tilt changes the direction of the lift force, allowing the helicopter to bank and turn smoothly. Mastering the cyclic control is essential for any helicopter pilot. It requires a delicate touch and precise movements to ensure smooth and controlled flight. By understanding and practicing these principles, pilots can achieve remarkable agility and precision in their flying. Altitude control, the collective pitch lever. While the cyclic governs horizontal movement, The collective pitch lever, or simply the collective, reigns over the helicopter's vertical axis. Positioned at the pilot's left side, this lever resembles a car's parking brake but serves a far more dynamic purpose. It controls the collective pitch of all the rotor blades simultaneously, directly impacting the helicopter's altitude. Raising the collective increases the pitch of all the rotor blades collectively, generating more lift and causing the helicopter to ascend. Conversely, lowering the collective reduces the blade pitch, decreasing lift and initiating a descent. The collective is essential for maneuvers like takeoffs, landings, and hovering. Section 5, Collective Up, Collective Down, Managing Engine Power and Altitude. The collective is intrinsically linked to the helicopter's engine power. This lever, located to the left of the pilot's seat, is one of the primary controls in a helicopter. It directly affects the pitch angle of the rotor blades, which in turn influences the amount of lift generated. As the collective is raised, demanding more lift, the engine must work harder to maintain the rotor's rotational speed. This is because increasing the pitch angle of the rotor blades creates more aerodynamic drag, which the engine must overcome to keep the rotors spinning at the necessary speed. To compensate for this increased load, the engine throttle is automatically adjusted in conjunction with the collective. This automatic adjustment is crucial because it ensures that the helicopter can respond quickly and efficiently to the pilot's inputs without requiring constant manual throttle adjustments. This interconnected system ensures a smooth and predictable response to the pilot's input. When the pilot raises the collective, the engine power increases seamlessly, allowing the helicopter to gain altitude smoothly. Conversely, when the collective is lowered, the engine power decreases, enabling a controlled descent. Raising the collective not only increases lift, but also commands more power from the engine to sustain it. This is particularly important during takeoff and landing phases, where precise control over lift and power is essential for safety and stability. Similarly, lowering the collective reduces both lift and engine power. This reduction is necessary when the helicopter needs to descend or reduce its speed, ensuring that the aircraft remains stable and under control. This delicate balance between lift and power is crucial for maintaining stable flight. Pilots must constantly monitor and adjust the collective and throttle to ensure that the helicopter remains in a stable and controlled flight path, regardless of the flight conditions or maneuvers being performed. Section 6, Cyclic and Collective, a harmonious duet for helicopter flight. The cyclic and collective work in tandem, granting the helicopter its unique maneuverability. The cyclic dictates direction and speed by tilting the rotor disc, while the collective controls altitude and power by adjusting the collective pitch of the blades. Mastering helicopter flight requires a delicate touch and a deep understanding of how these controls interact. It's akin to playing a musical instrument, where skilled coordination between both hands is essential for producing harmonious melodies. Section 7, Beyond the Basics, Foot Pedals and Anti-Torque Control. While the cyclic and collective are the primary controls for helicopter flight, a third element plays a crucial role: the anti-torque pedals. These pedals, operated by the pilot's feet, control the tail rotor, which counteracts the torque produced by the main rotor. Without the tail rotor, the helicopter would spin uncontrollably in the opposite direction of the main rotor's spin. The pedals allow the pilot to adjust the tail rotor's thrust, maintaining the helicopter's heading and enabling precise directional control. Section 8, The Art of Hovering, a Symphony of Control Inputs. Hovering, perhaps the most iconic helicopter maneuver, showcases the delicate interplay between the cyclic, collective, and anti-torque pedals. Maintaining a stationary position in the air requires constant adjustments to all three controls. The pilot must make minute adjustments to the cyclic to counteract any drift caused by wind or air currents. The collective must be finely tuned to maintain a constant altitude, while the pedals are used to keep the helicopter pointed in the desired direction. Section 9. Conclusion, the enduring allure of helicopter flight. Helicopter flight, with its unique challenges and rewards, continues to captivate the imagination. Understanding the fundamental principles of cyclic and collective control opens the door to appreciating the complexity and artistry involved in maneuvering these versatile machines. From search and rescue missions to aerial photography, helicopters perform a diverse array of tasks. And at the heart of their capabilities lies the delicate dance between the pilot's inputs and the responsive movements of the rotor blades, orchestrated by the cyclic and collective controls.